In this example, we want to determine this unknown current, I sub s, through this 6-volt voltage source. We have a couple of different options here, but either of them are probably going to require us to use KCL at the terminals of this source. So let's define a couple of nodes. I'll call this node A, and I'll call this node B. At A, we know the current coming from this current source, we know the current coming from this current source, and we want to know this current. We know 2 out of the 3 currents at this node. We're not so lucky at node B. We have a couple of other unknown currents through the 3-volt source and through the 4-ohm resistor. So to get the least number of unknowns, let's do KCL at A. And I'll arbitrarily assume that positive currents are leaving the node. With that assumption, 2 amps is leaving the node in this direction, so that's a positive 2 amps. 3 amps is entering the node from the 3 amp source, so that's a negative contribution, minus 3 amps. And I sub s is entering the node, which is also a negative contribution. Those sum to 0. If I do that arithmetic, Is is equal to minus 1 amp, and we're done with the problem. However, there's nothing wrong with doing KCL at node B, so let's take a look at an alternate approach. And again, I'll assume that positive currents are leaving. Now we have a couple of other unknown currents we need to account for. Let's call this current I sub 3 volts, and this current through the 4-ohm resistor I sub R. I haven't assumed anything about the polarity across the 4-ohm resistor, and there is no voltage-current relationship across the 3-volt source that affects how I should choose my current direction. So from node B, I sub s is leaving, that's a positive contribution. I3V is leaving, that's also a positive contribution. And I sub R is leaving, which is also a positive contribution. Those sum to 0. I have one equation, but there are 3 unknowns. In order to solve for I sub s, I need to write 2 more equations. Let's define this terminal down here as node C. Now if we do KCL at C, I'm going to stick with assuming that positive currents are leaving the node. So 2 amps is entering, that's a negative contribution, minus 2 amps. I3V is entering, that's also a negative contribution. Those sum to 0. That gives me I3V is equal to negative 2 amps. It's another equation, so now I have 2 equations and still have 3 unknowns. We need to write another equation. Let's call this terminal up here node D. Now if we do KCL at D, I'll stick with the assumption that positive currents are leaving the node. 3 amps is leaving node D, so that's a positive contribution. IR is entering, so that's a negative contribution. So IR is equal to 3 amps. That gives us our third equation. We can solve this equation, and this equation for I sub s. That's an easy process because these 2 equations give us numerical values for I3V and IR. So this equation becomes I sub s plus I3V, which is negative 2 amps, plus I sub R, which is 3 amps, is equal to 0. If I solve this, I get I sub s is equal to negative 1 amp. The 2 results that I get agree. So as long as you don't do anything wrong, you should get the correct answer. Now some approaches might be quicker and easier than other approaches, so you probably want to take a look at the problem for a while before you jump in and start writing equations, but it's not the end of the world if you choose an approach that's more work than some other approach that you didn't notice.